Hey everybody, welcome to Mr. Curl's Classroom. Today we're going to talk about absolute value equations, so let's go ahead and get started. Okay, so let's first define an absolute value equation, and actually there are quite a few different definitions for an absolute value equation. So let's cover some of the main ones. Um, the first one is probably the simplest one, and it says that the absolute value of x, and by the way, the absolute value symbol are these little pipes, if you want to call them, or vertical lines. But anyway, the absolute value of x is the non-negative value of x without regard to its sign. So let's go ahead and take a look at an example of what that's trying to say. Well, it's essentially saying that if what's inside of that absolute value is negative, it gets turned to a positive. But if it was positive to begin with, it's still just going to remain positive. That's it. So really it's kind of referring to the absolute value as an operation, like addition or subtraction. What does the operation do? Well, it essentially just turns whatever is inside into the positive version of itself. That's essentially it. All right, so let's go ahead and take a look at another definition. And this one you might be familiar with here. This one relates the absolute value to a real world physical measurement. And it says the absolute value of x is the distance from x to 0. Okay, so let's take a look at an example of that. So if I'm given a number line and then I'm given some kind of absolute value problem here, like the absolute value of -5, what does that equal to? Well, what does that mean? Well, on the number line, if we put a point at -5, it's really saying, according to this definition, what is the distance from -5 to 0? And if we go ahead and count that out, then that distance is +5. So there we go. We have our answer of +5, right? Pretty easy. And by the way, why is it turning that distance not -5? Why is it turning into a positive? Well, because in the real world, right, we can't have a negative distance. When we measure distance, it is always positive. Okay? And here's another example. If we're on the positive side, absolute value of 4, well, this definition says, well, what's the distance from 4 to 0? Well, that distance is +4. So there we go. We have our answer of +4. Which brings us to our last and most technical definition here. And it actually brings up a few more complications. Absolute value of ax plus b, right? We still have the x, like the absolute value of x, but in this case, they're adding some more in there. Well, x could be multiplied by something, in this case a, or we could also add some things to it, in this case b. So we're saying ax plus b as our expression. Regardless, in this particular case, we are breaking up this solution into two different cases. And I'm going to actually start at the bottom here and say, well, what is case one? Well, if whatever's on the inside here was positive, what did we say? Well, it just stayed positive, right? And that's what it says here. If ax plus b is greater than or equal to 0, or if it's positive, then it's just ax plus b. That's the answer. However, case 2, the upper half here, if ax plus b was less than 0 or negative, then we need to change it into its non-negative form. So what do? Well, we're just going to multiply it by a -1, essentially, right? To turn it into a positive, to get to that positive version or non-negative version of itself. Okay, so there we go. Those are the three definitions that we're going to cover today. And actually, at this time, what I'm going to do is I'm going to take a deeper look at definition number 2, because although it's true that the absolute value of x is the distance from x to 0, what if we didn't have just the absolute value of x? What if there was something more inside of here? So let's go ahead and we're going to go ahead and take a look at that. Okay. Okay, so here we are with our definition that we were left with. The absolute value of x is the distance from x to 0. But what I'm going to actually tell you is that it's really the absolute value of x minus h is equal to whatever the distance is. All right, d standing for distance. So what does that h actually mean? Well, in this case, it's really the distance from x to h is our distance, right? That's what the distance is equal to, x to h. So you might be saying like, whoa, hang on a second. Like I always thought it was from x to 0. So why is the absolute value of x different? actually it's not. If you take a closer look at the absolute value of x, you could write it as the absolute value of x minus 0, right? That is the same. That is equivalent to the absolute value of x. So in this case, it is still the distance from x to h. In this case, it's just h is 0, so from x to 0, okay? So I want this to kind of stick in your mind here, that it's really the distance from x to h, and it's also negative here, by the way. It's x minus h, okay? So that's something to be aware of, okay? Let me show you an example. So if we have this example, absolute value of x minus 3 is equal to 2, graphically speaking, because this is kind of like a graphical representation of this definition, what does that look like? Okay, well, first of all, it means that we're asking, well, what's the distance to 3? Because h is 3 in this case, you guys. It is not negative 3, right? The definition is x minus h. So in this case, h being 3. If h was negative 3, then it would actually be x plus 3, because it would be x minus negative 3. Okay, but either way, x is 3. So in this case, we're going to call this the midpoint, and you're going to see what that means in a second. And what is that equal to? Well, I've already defined a distance, and I'm saying, well, it's equal to 2. And so the distance is actually 2. In other words, the distance in both directions. So graphically speaking, what is that going to look like? Well, it looks like this, right? X minus h, or x minus 3, well, the midpoint is 3, so what is the distance from 3? Well, in this case, I actually gave you the distance. I said it was 2. But which direction? Well, that's the absolute value, right? It could go left or it could go right. In this case, 2 to the right or 2 to the left. In this case, I'm actually showing you the answers to this equation. The absolute value of x minus 3 is equal to 2 is actually x is equal to 1 and x is equal to 5. So remember, it's the distance from h, so what's inside of there, and then this actually will tell you the distance if you have a number off to the right. Okay, distance to the right and to the left. Okay, so there's a little extension on that particular definition. Okay, all right, let's move on. Let's talk about solving. Okay, so step one is always going to be to isolate. All right, and actually that's how pretty much all of math goes. Okay, so whenever you have any type of complication, something that looks difficult in a math equation, in this particular case I've got 3 examples here, and that difficult thing is the absolute value. Well, what I need to do is try to reverse that or undo it, but you should always isolate it first. If you don't, then you do some algebra on it, then it could end up going in the wrong direction or becoming more difficult than it originally was. So always isolate. So what we're going to do is we're going to take all 3 of these and we're going to isolate the absolute value. Okay, so let's go ahead and see what that work looks like. So here we go with the blue, right? All I did was add 1 to the other side, and now the absolute value is isolated on the left. In the pink here, I divided both sides by 3, and so I got absolute value of x plus 2 is equal to 2, because 6 divided by 3 is 2. And for this yellow one down here, I had to do a couple of operations. I first subtracted 1 from 9 to get 8, and then I divided both sides by -2 to get -4. Okay, so step 1, isolate. And we always isolate on the left, just so you guys know. That's just our convention. Okay, make sure we're all on the same page. All right, now step 2 is going to be separate into those 2 cases, right? Remember, whenever we have any absolute value, it could be a positive on the inside, a positive version of itself, or it could be a negative. Okay, so what does that look like? Well, essentially, it looks like this. So let me guide you through each one of these. So case 1 is assuming that x minus 3 is positive. Well, what was the definition here? Well, it was literally just writing down this exact same thing, only drop the absolute value sign. So if this was greater than or equal to 0 from that third definition, then it's just x minus 3 is equal to 1. There you go. So there's your first case. right? And actually, I'm going to go through first case for all of these. So for the pink one, if the absolute value of x plus 2 is equal to, well, if we say, well, if this is positive on the inside, we just drop the absolute values. So case 1 is just rewrite it. X plus 2 is equal to 2. And then for the yellow one here, again, just rewrite it. X plus 1 is equal to negative 4. That's it. All right. Case 1 is always just rewrite it without the absolute value. Case 2 is, and if you go back to that third definition, well, if it was negative inside of here, in this case in the blue, if x minus 3 was negative, then how do we get our answer? Well, we had to negate the other side, turn it into a non-negative. In other words, multiply it by negative 1. So case 2 is, yeah, write the exact same thing down, drop the absolute value, but you need to multiply the right-hand side by negative 1. So this is x minus 3 is equal to negative 1. The pink one, x plus 2 is equal to negative 2. And the yellow one, x plus 1 is equal to positive 4. Negative 1 times negative 4 is positive 4. Now I will stop here and just mention this. These all happen to be very simple on the right-hand side. If it was more complicated, like x plus 2 or the square root of x minus 1, then you have to multiply the entire right side by that negative 1, okay? So put parentheses around the right-hand side and multiply it by negative 1, okay? There we go. These just all happen to be simpler problems. Okay, so there we go. You can see from an absolute value equation, we always get 2 answers. Well, actually, that's not entirely true. One of these is false. And you may want to pause the video and just kind of look at each of these and try to determine for yourself which of these 3 is actually incorrect. Okay, so if you paused the video, so first of all, let's go ahead and we would actually write our solutions here, right? So solve for x in each one of these cases. But which one was incorrect? Well, actually was the yellow one. Why does this not work? Well, first of all, you could plug these back in and you'd get the wrong answer, okay? It wouldn't work out if you plug these into these solutions back into the original. But if you stop at the point where you isolate these, like here, for example, in the blue, x minus 3, absolute value of x minus 3 is equal to 1. Is that possible? If I turn this, can I turn something in here into a positive 1? Well, yeah, no problem, right? That's what absolute value does. It turns things positive. What about this pink one? Can I turn this thing inside of here into a positive 2? Sure, why not? But what about over here? Could I turn, it doesn't matter what's inside of here. It could be some crazy expression, but it doesn't matter because whatever is going to pop out of it has to be a positive number. That's what the absolute value does. So could I ever change or take the absolute value of anything and get negative 4? No, impossible. Can't take an absolute value and get a negative number. So you could have just stopped right here and said, nope, no solutions to this. However, this is a good point to make. Always check your solutions because they definitely would not work here. Okay? All right. So let's go to a couple of practice problems. We're just going to do a few of them. Let's go to problem number 1. Okay, so here we go. So let's go ahead and work this one out together. Whoops. Lost my colors, sorry. Hopefully it's white. Yes, it is. Okay, good. Sorry about that. All right, so let's go ahead and work this out. So step 1 is isolate this complicated thing. And again, if you have anything complicated like a square root or something squared, whatever, you're always going to isolate that complicated thing. So let's go ahead and do our basic algebra. So first I'm going to subtract 5 from both sides, getting the absolute value of x minus 4 is equal to negative 8. Now, this negative cannot stay here. I do have to get rid of that. So I'm going to divide both sides by negative 1. All right, getting the absolute value of x minus 4 is equal to positive 8. Okay, now we're isolated. Step 1 is done. Step 2, create our 2 cases. So here's case 1 which is just rewrite it with dropping the absolute values. So x minus 4 is equal to 8. Case 2 is x minus 4 is equal to, and I got to multiply the right side by -1, which is just -8. And there we go. Let's go ahead and solve. So x is equal to, I'm going to add 4 to this side, 12. X is equal to, add 4, -4. And there we go. We have our 2 answers. Okay? All right, let's do another problem. Next problem here is a little bit more complicated. So let's go ahead and do step 1, which is isolate. So I'm going to first subtract 4 from both sides. So I am left with -5 times 5x plus 2 is equal to -40. -36 plus -4. Let's see here. I'm going to divide both sides by -5. So we get the absolute value of 5x plus 2 is equal to +8. Right? -40 divided by -5 is +8. All right. Next step here is going to be our 2 cases. So we'll say case 1, case 2. Whoops. Case 1, again, we're just going to rewrite dropping the absolute value. So 5x plus 2 is equal to 8. And case 2 is 5x plus 2 is equal to, now multiply the entire right side by -1. In this case, it's just -8. All right, now we solve. So I'm going to add 2, subtract 2. So I have 5x is equal to 6. And now I'm going to divide by 5. X is equal to 6/5. All right, and case 2, I'm going to again subtract 2, getting 5x is equal to -10. Divide by 5, x is equal to -2. All right, there we go. Our 2 answers. Let's do one more. All right, so this one looks simple enough. Let's go ahead and isolate step 1. So I'm going to subtract 1 from both sides. So negative absolute value of x plus 7 is equal to, and then I'm subtract 1. So 7 minus 1 is, 8 minus 1 is 7. All right, now I'm going to multiply both sides by -1 or divide by -1. Same exact effect. Ultimately, we need to get rid of that negative on the left-hand side. So absolute value of x plus 7 is equal to -7. And right now, I always look at these. I stop at this point of isolation, and I'm going to say, well, hang on a second. The absolute value of anything doesn't matter what's inside of here, right? Could it ever be a negative number? No, the absolute value turns things positive. So that is impossible. So we'll say no solution. All right, and there we go. All right, guys, so there was a quick lesson on absolute value equations. Hope you enjoyed it. Hopefully you got something out of it, and I'll see you guys in the next one. Take it easy.